Hi everybody, welcome back. We are continuing, welcome back to my physical world. We're continuing our talk about LiDAR and how I use it and the things that we're doing. Now you've learned how to add in LiDAR. I haven't showed you how to download it if you have it available, but I'll do that in another video. But anyway, what have I been using this LiDAR data for? Well, like I said in a previous video, I am doing a history of glaciation here in Huron County, Ohio. And three-dimensional objects are better for analysis for doing glacial features, such as eskers, kames, kettle lakes, end moraine, that kind of thing, because they pop, they show up really well. So we're continuing both our learning about LiDAR and also learning how I use LiDAR in my research. So from last time, we learned how to create a raster digital elevation model from a last data set. And we also learned how to do hillshade analysis or create a hillshade surface for visualization. We also brought in our county roads on top of that, just so you can see that your data, if your projection data is correct, your normal data sets can drape on top of your last data set. Okay? I think that made sense. All right. Now, what do I use this for? Well, once I get the visualization set up the way that I need it to, so I can identify features a lot better, then I can actually start going to work. Now, I do use some other data sets in order to help me kind of fine-tune the locations that I'm looking for. The Ohio Department of Natural Resources has a plethora of information that you can use for research. And I was interested in finding any surveys of glaciation in Huron County. Well, I did find some documents from the Department of Natural Resources where they have gone out and delineated glacial landform types. Even though it was crude, it got me in the area of where I wanted to do a closer look at these features. All right, so I'm going to add a feature. I'm going to add a layer here that I have downloaded from ODNR, and I have a polygon layer, and I call it Ohio Glacial. And I'm going to change some symbology here just so we can look at it a little better. I'm going to change it to just some lines, okay? So I have these red boundaries, and these are coming from a manuscript that I found that I registered to my state plane coordinate system and then redigitize them so I can have them on my base map. All right. So these polygons that you see are a generalization of glacial features in Huron County. These polygons right here that I'm kind of tracing with the hand here are evidence of eskers and kames glacial features in Huron County. This zone down here is a ridge moraine field, or could be a what you call a terminal moraine in this case. It was just one advance of the Wisconsin glacier. And then up here, this big area around here, this is just all ground moraine. Just normal till that's brought down by the glacier during its progression and regression. All right. So I have a ballpark study area based on the polygons that were provided by the Ohio Department of Transportation. But my goal is to make accurate maps. And that's why I use the LiDAR. I use their zones, like this big polygon here, to kind of zoom me in a part of the county that I'm interested in, and then I use the LiDAR information, my hill shade analysis and all that, to actually find the features themselves, okay? Now you notice that this big polygon right here is a zone for eskers and cames, okay? But when I use the hill shade analysis, that esker stuff doesn't really come over to this little small town. The eskers you can plainly see with the hill shade analysis are right here. All right. So basically what I do is I zoom in, and then I use my tools to digitize around the actual features themselves, so I can create a better representation of this particular glacial landform in our county. And I have a layer that I started, and that one I call eskers, and I'm going to add that to our project here. And these are polygons that I digitized on top of the eskers. Now these are just preliminary polygons that I'm still working on. But I'm able to use the LiDAR data with the hill shade and go in and find these zones and find these features and make a more accurate map of, in this case, eskers in our county. Like there's one right here that I haven't digitized yet. This feature right here is a cames, which is basically an esker is a long snake-like ridge that's created underneath the ice. Well, a cames is almost the same thing, except it's a depression that is filled in with that till or that unconsolidated material. And then when the ice melts, you have a mound of debris that's sitting there. So I still have some mapping that I'm doing. Here's another cames right down in this corner here. It's inside this esker cames zone. So that helps me identify that. All right, now what I want to do is I'm going to switch projects. I'm going to close this one out. I'm not going to save it or anything, but I'm going to open up another project that I have going. And that one is called Huron County Glaciers. Where is it? Huron County, oh no, Huron County LiDAR is what I called it. So I'm going to open that up. Not going to save this one. And what this one is almost the same kind of stuff that I just showed you how to do, except I have it based on the entire county. All right. Our county is approximately 28 miles wide by, 20 miles north and south by 28 miles east and west. All right. So this is practically the same area. Okay. Now, the one thing that I want to show you about LiDAR is, now this is the entire county. I created a last data set of every last data file in the county, and there's like 400 of them for our particular county. So some of the drawings might take a while, but bear with me. All right, so I basically did all the steps that we did in the previous videos. I created a digital elevation model, and I created a hill shade, except I did it for the entire county. All right, So I can use these for visualizations just like I did before. And then I created, and here's the LiDAR actual data that I symbolized in this particular color ramp. Now, what do I use this for? The first thing that I need to tell you about LiDAR data. Okay, so I'm going to turn off the roads. I'm going to turn off the lakes and ponds and things, and turn off my Ohio glacier source table that I got from the Ohio Department of Natural Resources. But I want to show you what happens to LiDAR data when you start zooming out. Okay, so I'm going to zoom out, and you're going to watch. Notice that now I'm not getting the LiDAR data. I'm getting all these little red squares. Okay, and each one of these red squares is an individual LAS file. Now, they're not individual because I have combined them into a data set, so I get to look at them all at the same time. But LAS data files and data sets are dependent on scale in order to actually see the LiDAR information. All right, so if I zoom out, right now I'm at a scale of 400,000. My LiDAR data is not going to show up until I start zooming in and it can catch the information that I'm looking for. So I'm going to zoom into this little area of the county. And it's going to take a while because, like I said, this is LiDAR data for the entire county. All right. So I'm waiting for all of these to render. All right. So you notice as soon as I zoom in to a certain location, and it kind of looks pale right now because I do have transparency set because I have hill shade underneath that I can bring in if I wanted to. Okay. But the LiDAR data doesn't show up until I get to a certain scale. Here I'm at 30,000, a scale of 1 to 30,000. But if I break out of the 1 to 30,000, I think I'm going the wrong direction. Yeah, I'm actually getting tighter. But if I zoom out, I'm going to try this again. Sorry about that. And we're going to move out to a scale of, let me see where it's at. Yeah, okay, so here's a scale of 1 to 40,000. The LiDAR information does not show up. I get the boundaries of all the different panels. And each panel in a LAS data sheet, LAS data file, is 5,000 feet by 5,000 feet square. All right. But in order for me to see the detailed information of the LiDAR, I have to break that scale of 30,000. So if I zoom in a couple times, now I'm at 1 to 25,000. Now I'll start seeing the LiDAR data show up. Okay, so here I have a river stream coming through here. All right. So that's what happens when you have a large LAS data set. Your data is not going to show up until you get zoomed in enough, about 1 to 30,000 scale, to actually start seeing the 3D analysis start running. These are massive files. I mean, each one of these has each panel has anywhere between 250,000 to 750,000 data points. So the software is kind of keeping us in check. But if you notice, if you look at the LiDAR information, I can see very easily three-dimensional space from that laser readings. Okay, so right here you see this ridge that kind of curves around like that. Well, that's a bypass that goes around a town that sits in this area. Okay, if I come up here and I turn on the county roads, you'll see the city show up, and there's that bypass that goes around the city. Okay, but also you can see other geographic features, and using support data like the information that I got from the Ohio Department of Natural Resources to find areas that they identified as glacier zone type of features, I can start making out those features from my data sets. Like this ridge right here, coming along the map. Whoops. Let me zoom out. I kind of screwed that up, didn't I? Sorry about that. Let's zoom back out here. Boy, I really screwed that up. Where did I go? I'm somewhere around here. We'll get there. Please hold. I'd play some hold music, but you don't want to hear that. All right, but see this ridge right here? This ridge, which actually follows a street that's in town, this right here is an ancient lake shoreline of what is now Lake Erie, but back then it was called Lake Warren. And I can easily map that boundary because I can see the three-dimensional space of where that glacier feature is using this LiDAR information. Now, if you look over here, there's a little subtle one here and a little bit more prominent ridge right down here. And these go all the way up toward Cleveland. This right here is where ancient Lake Whittlesea used to be, okay? So what I'm gonna do is I am going to add in a data set, and I'm going to add in both Lake Warren and Lake Whittlesea. Add those in. And so I have two layers. I have Lake Whittlesea here. We're going to change its color to a darker blue. Well, not quite that dark. I'm going to change it to this dark. Get rid of the outline. Hit OK. Hit OK. Okay, so that's Lake Whittlesea. And then on top of that, I need to change the order because Lake Whittlesea came first. So Lake Warren sits on top of Lake Whittlesea. These are post-glacial lakes that formed prior to Lake Erie. So change some symbology here just for cartographic sake. And let it draw again. All right, now these boundaries here are based on geologic records from 1915 from a glaciologist that did a huge study in this area. And based on his data, I was able to map where the edges of these ancient lakes used to be based on the elevation that he estimated that the water level was at, okay? Lake Whittlesea was approximately 800 feet. It was actually 775, but in elevation. And Lake Warren it actually had three phases, 690 feet, 680, and 670. So those figures were used to delineate the elevations based on the LiDAR of where those elevations actually fell. All right, so what I'm going to do is I'm going to transparency Lake Whittlesea a little bit. We're going to make those 60% so you can see the underlying features, hopefully. There we go. And then I'm going to transparent Lake Warren to 60%. That way we can see the LiDAR information underneath the where the water's edge was. Now, if you remember, I was telling you that this line right here was a lake boundary at one time because of that ridge right there. Okay, this is an ancient shoreline. Now, if I took the data that this glaciologist put together for his estimate of where the lake was, we can find that he was close, but he wasn't really close enough. All right. Now, he has a lot more information that he's basing his data on, so he could have been right, but it clearly shows that right here is a boundary, and based on the sand sediment that's been found in this area in this town, that the lake actually came up to this ridge. And it's the same thing with Lake Warren, which is this darker color here. Here is the extent of the lake. It never reached past this green area, all right? But it's pretty darn close. It follows this contour line basically pretty darn close, back and forth like this. But we also have to remember that these lines that I created from the LiDAR based on this glaciologist's field data is where these lines show up on the current Earth's surface. And we have to remember that the current the Earth's surface was probably a lot lower down during this time, okay? So we can use LiDAR data to supplement field notes from scientists out in the field to find how close they are with their estimates of where features were. Okay, in this particular case, glaciated features. Now, another thing I want to show is I'm going to show you an arc scene, which is a three-dimensional representation of the Earth's surface. I'm going to open up a project that I saved using this same data, except I have put it in three-dimensional space. It might take a while to load because it's pretty big sized. But arc scene is ESRI's three-dimensional visualization and analytical tool. It used to be called 3D Analyst way back in the day when we first started GIS. But arc scene, you can visualize things 3D, make some pretty impressive 3D looking maps and stuff. All right. So this is going to take a little bit to draw, and I'm sorry for any white space that we have going on in our presentation. But this is the entire county, and I'm doing this live. That's why it's taking so long. I didn't put any pre-stuff in the oven waiting for us. But ArcScene allows you to take your data and create 3D views, kind of like we did with the last viewer, the last data file 3D viewer, except with ArcScene, you can be more realistic with it. You can bring in other layers and lay them on top of other layers. There it comes. Sorry it took so long. All right, so here I have three-dimensional space. These are the same layers I had in the two-dimensional space, except I put them in 3D so we can visualize them. Now, I have this gray is all the hillshade analysis that I did for the county, and then the color part on top of it is the last data set draped on top of the hillshade, so you can see the county in 3D. Now I'm getting some interference, that's why I'm getting these splotches of colors, and that's something that I'll have to just go in and check some of the settings on how I visualize these 3D. But anyway, we're loading the three-dimensional hillshade analysis over the digital elevation model. In this case, it's the LiDAR data. We're just draping it on top and then visualizing. But if you notice up here, I've brought in Lake Whittlesea and I've also brought in Lake Warren, those two ancient glacial lakes. And I've draped it, or actually I've set them at their actual elevations that glaciologist said that those lakes were at. So you can visually see in 3D. Now the red lines are those feature areas that the Department of Natural Resources had. And then now I'm going in and fine tuning them and actually mapping the actual features themselves so that it's more accurate than what the ODNR had. Okay, so we have some eskers and some cames in this area here, and then way up here in the northeast part of the county. So that's just one example of what you can use LiDAR with. And if you have any questions or comments, please leave them with me, and I welcome, and I'll try to answer them if I can. And if you have any helpful tips, I welcome those comments as well. So that is LiDAR, basically LiDAR in a box, I guess. So I hope you guys enjoyed the video. Please subscribe, leave comments, and press the bell for notifications. We'll see you later.